Day one, birthday. There it is. 4 years later, or at least 3 years, 11 months or so, and 50,000 miles, and in need of a wash. Still goes great though. You'll notice on the back there's no designation for the battery size. That's just how they came in early 2013. This one's actually a 60 kilowatt hour. Just under 50,000 miles. I've used 16,500 kilowatts. And my average 332 watt hours per mile. Now Tesla rated range assumes you're doing 300 watt hours per mile. So I've done about 10% worse than that. So my range is a few percent lower than what Tesla says I should get. Now it really depends on the type of driving I'm doing. So if I'm on the freeway and I'm doing 70, 80 miles an hour, which we can do here in Texas, my usage is a lot higher. If I'm going around 60, my usage average is much lower, and in fact I can easily get well under 300. So with these figures, I was just working out over 4 years, that's about 12,500 miles a year. It's about 1,000 miles a year, and with my price for around $45 a month, it's a little over 4 cents per mile it's cost, which isn't bad. Incidentally, it's pretty chilly outside. It's just gone over freezing now, and from the orange energy meter you can see it's not sitting at zero, even though I am actually sat still at 0 miles an hour with the parking brake engaged, and you can see energy is being used right now. That orange bar is just flicking up and down periodically, and that's just due to the cabin heater. That's the only thing that's running right now is the heating, and so you can see that it's using up energy just going nowhere. And so that's why during colder spells the watt hours per mile figure gets considerably worse, and at this sort of temperature I find it very hard to get anywhere near 300 watt hours per mile, and it's quite often much higher up. So you can see, I didn't go very far here, just a mile or two, but yeah, it's often nearer 400 watt hours per mile. So if you're driving in winter, you do have to budget your battery a lot more carefully. You're going to use up more battery as you drive, especially initially when the battery's cold, because it does warm up the battery. So for the first 15 minutes or so of driving, the battery heater is on, and that uses quite a bit of power. It's not even warming the cabin, it's just warming the well, it is warming the cabin as well, but it's warming the battery, and that uses a lot more power than warming the cabin alone. So if you only do a short drive in the middle of winter, you'll see your watt hours per mile be quite high, because you're within that first 15 minutes or so, and a lot of power is going to warming the battery. After that 15 minutes, your watt hours per mile drop off to a more normal level. Still higher than normal because you've got the cabin heater on, but that first 15 minutes or so can be quite a shock when you first do it, because you seem to be using a lot of battery for the distance traveled. But like I said, it is temporary, because once the battery pack's warmed, that heater turns down a lot. So normally when I charge at night, I have a NEMA 1050 outlet. I could get 40 amps out of it, but with my house electric and my AC units and so on, quite often 40 amps trips up, and the car will go down to 30 amps, and sometimes even just stop charging. There's too many other spikes going on around with the neighbors, I guess, or I don't know exactly what. But 30 amps, it charges just fine. So I normally just leave it on 30 so I can be assured of a full charge. And frankly, that's fast enough nearly all the time for my charging. I also usually have scheduled charging on to start sometime in the morning, early at night, so that my battery is as full as it can be for the morning when I leave. Otherwise, you do get some vampire drain. So if the car's just sitting there, so this minimizes that. I don't need to do this. I could just have it charged when I plug in, but this gives me a couple of extra miles when I get going in the morning. Tonight, since it's so cold, I'm actually going to try and time things so that it's charged up to full, or well, 90%, about when I'm going to leave. So the battery's nice and warm, and I won't need to run the battery warmer off of the batteries while I'm driving around. My 90% is about 175 miles roughly, so I need to gain about 50 miles. This is like 18 miles per hour, so it's going to take about 3 hours. So if I'm going to leave around 8 tomorrow morning, if I start the charge around 5ish, I'm actually going to do, let's say 4:45. That should give it time to charge up. It'll start charging at 4:45 in the morning. It'll warm up the battery doing so, and by the time I leave about 8, the battery should be nice and warm, fully charged, and good to go. Well, thanks to the vagaries of timing and the battery management system, this morning I start out with 177 miles, one more mile than yesterday. The battery's a little cooler, so this orange dotted dashed line here means that battery regeneration will only go up to that level. And the battery's, there you go, starting to blink. The battery's just warming up, there we go. And now I've got full regen back. You can see I'm not going anywhere right now, but the heating's on, so we're using kilowatts. And right, off to work. So my daily plug-in when I get home, in it goes, and the car will charge as scheduled. And that's it, all I have to do. No gas stations, I don't have to go anywhere to fill up. It's just like charging your phone. Just plug it in. Going for dinner now.